All right, here we go. Section 2.3, day 1. Today we're going to work on using long division to divide polynomials by other polynomials. And then once we go through that, we're also going to cover synthetic division today to divide polynomials only when it's in the form x minus k. All right, so as a little intro or segue into long division with polynomials, we're going to review long division with just numbers, okay? I don't think we need both of them, so let's just slow down and take our time with number 1, and we'll probably skip 2. All right, what you're dividing by actually has a name. It's called the divisor. So that's the number that always goes out front of the long division, okay? The dividend is what goes under the division sign. All right, so the divisor of 4, we put here, and the dividend is the 1,246, okay? All right, so with long division, you start with the number that 4 goes into. So 4 doesn't go into 1, so I'm going to move over a place value to 12. All right, I'm going to ignore the 46. So 4 goes into 12 how many times? And we say 3. Okay, and now what you do now is take 3 times the 4 is 12, and we write it underneath this 12, still kind of ignoring this 46. All right, and then we subtract that. And obviously we get 0. Okay, now you can bring down the next digit of 4. And we begin this process again. Now, if 4 didn't go into this number, like this was a 3 or a 2, I'd bring down the next digit. But as long as it goes into this number and we can get an answer, we continue. 4 goes into 4 once. 1 times 4 is 4, and I write it here. And subtract again. So 4, take away 4 is 0. Carry down the next digit, okay? All right, down to the last step. 4 goes into 6. How many times? 1. So 1 times 4 is 4. We subtract it again. 6 minus 4 is 2. Okay, there's nothing more to carry down, so this means this is the remainder. So we have 311 with the remainder 2. Okay, or another way to write this is 311, and you can put 2 over 4, what you divided by. 311 and 2 fourths are 311 and 1/2, or 0.5. Okay, so if they ask you to list the remainder, that's what we do. But if you need to change the fraction form, we do 2 over the 4 to get to 1/2. Okay, all right, so why did I review division with numbers? The steps are very similar when we do division with polynomials. Okay, just a little different flow. Okay, so let's go down to number 3. We should make note too, whenever you have a missing term, like here it says we're going to divide this by that. Okay, so this is called the divisor, so that's what we put out front. Notice that the x squared term is gone. So to get things to line up correctly, we always want to put in like a 0x squared right here. Trust me, it just gets things lined up. Okay, so that's what this note is saying here. Always use zeros when you have missing terms. Okay, and also you want it in standard form. Put it in order. If this was not in order, like the 2x cubed was last, we would want to write the 2x cubed first. Okay, descending order in terms of degree. All right, so let's get started. So to get this going, just like we looked at 4 goes into 12 how many times, you want to look at the leading terms. I want to focus on x and 2x cubed. I basically need to answer this question. X times what gives me that 2x cubed? Okay, so the answer to that is going to be 2x squared. Okay, so that's what I put up top here. All right, so just like when we got this 3, what do we do next? We did 3 times 4, we put that answer, and we subtracted. So I got to do the same thing here. I do 2x squared times this entire quantity. So that gives me 2x cubed, and then 2x squared times 1 is 2x squared. All right, here comes the number one mistake in this process. When we subtract this, students forget that they're subtracting when they go on to the next terms. So for example, 2x cubed minus 2x cubed That's gone. It's 0x cubed. I don't think I need to write 0x cubed. But this next step, students will just write 2x squared. You got to remember to subtract. Quite often, you're going to see me circle this to remind you to subtract everything. And I encourage you to do the same thing. So 0x squared minus 2x squared is a negative 2x squared. Okay, carry down, because we're done subtracting, so now we carry down the rest. Okay. All right, and then we restart this process again. So I'm going to ask myself now, x goes into this leading term how many times? So I'm asking this question. X times what gives me negative 2x squared? Well, what am I going to need here? I'm going to need a negative 2x. Okay. Now I take this term, multiply it by this. So negative 2x times x is negative 2x squared. They should be the same if you're doing this right. We want those terms to cancel. Then negative 2x times this positive 1 is minus 2x. Subtract. Again, I'm going to circle this so we don't forget. A negative 2, this becomes a positive 2 when I subtract a minus, so that's gone. Negative 4 plus 2 is negative 2x. 1 minus basically is 0 here. So 1 minus nothing is positive 1. Okay, we have one more step because x still goes into negative 2x. So I'm asking this question again. X, look at the leading term. X times what gives me that negative 2x? And the answer is just negative 2. So negative 2 times x minus 2x, negative 2 times positive 1 is minus 2. Okay. Subtract. Circle it to remind. Negative 2 plus 2, 0. 1 plus 2 gives me 3. And I'm done. X no longer goes into 3, right? We need to have the degree higher or the same. Now the degree is lower, so that's the remainder. So here's how you write the remainder. Just like we talked about up here, it was 2/4. Now it's going to be 3 over my divisor. So we say plus 3 over x plus 1. There's the answer to problem 3. Okay. All right. Why don't you try 4? Let's see how we might need all 3 of these here. So why don't you pause, give yourself a minute or two to set this up and divide. 5, we don't have enough room. I'll probably do 5 up here just to make sure we have enough room. Okay, go ahead, pause and try 4. Okay, so here we go. It's kind of halfway done. X goes into x cubed, x squared times. Now I take this and multiply by this. And that result is here. Here we go. Good checkpoint to see if you paid attention to the minus here. That's gone. 2, this becomes a plus 1, right? Minus a negative 1. So 2 plus 1 is 3x squared. Okay, now we're done subtracting that. So you carry down the rest and then you start the process over again. Okay, now we're focusing on x and 3x squared. How many times does x go into 3x squared? The answer is 3x. So now I take 3x, multiply by this, and then I get this result. Okay, if I'm going too fast, pause and catch yourself up. All right, so then we subtract. So that's gone. Negative x plus 3 will give me positive 2x. Minus 2, subtract nothing is minus 2. Okay. All right, x still goes into 2x, so I got one more step. It goes in there 2 times. So I'll put that here, and then 2 times x minus 1. It's going to be 2x minus 2. So subtract those, and they're the same thing, so we actually get 0. Okay, so no remainder to report for this one. That might happen sometimes. Here's the answer. All right, let's take a look at 5. Here's what's different about 5. Well, we did have, I was going to say, we haven't had to throw in the zeros yet. We did in 3. It was kind of done for us. But here we have this divided by 2x squared minus 1. Notice the x cubed term is missing and the linear term is missing. Okay, so go ahead and pause this if you need to and write this down. And then I'm going to continue taking you through this. All right, so 2x squared goes into 8x to the fourth. How many times? 4x squared. Okay, a lot of times they'll line it up here right over the term. That doesn't really matter. All right, so 4x squared. Multiply now. This times that, 8x to the fourth. This times that is minus 4x squared. Take note now, I'm not going to write minus 4x squared right here. If I did, I wouldn't have the like terms lined up. This might throw some of you off because every single time like terms have been lined up. So don't write it there. Scoot it over under the x squared term and write it like this, minus 4x squared. Okay, so you kind of have another gap here. I mean, we can even write 0x squared if you want to. And subtract. So this is gone. X cubed minus, I mean, you have 0 and 0, so there's nothing right here. Negative 2 plus 4. It's positive 2x squared. Okay, so I'm done subtracting that now. Carry down this rest, the rest of the stuff. So 0x plus 10. Okay, it looks like it's going to go in here one more time. So when I restart this, okay, when I restart this, 2x squared goes into 2x squared one time. So I'll multiply again. 1 times that. 1 times that. It's negative 1. Once again, I don't want to write it here. I'm going to line it up under its like term right here. Subtract. Gone. 0 minus is nothing. Got nothing to write. 10 plus 1 is 11. Okay. So I guess I didn't need all that extra space. Pretty short problem, really, because this doesn't go into 11 anymore. So this is my remainder. So we write plus the remainder over our divisor. Okay, so that's long division. This doesn't cover every single scenario you're going to see, but it's a good foundation. Don't forget to add those zeros. Don't forget to get things lined up. And don't forget about that minus sign when you try these on your own. Okay? All right. All right, I'm going to end this video, and then video 2 will be synthetic division. Okay?